Welcome to The Explainer. Today we're zooming way out on the AI revolution. We're going to map out the entire architecture, everything, from a single line of code that can dream up a new drug, all the way up to the planet-sized infrastructure that powers it, and then to the global rulebook that's literally being written as we speak. Okay, let's jump right in.
So to really get the scale of what's happening, let's start in a field that affects every single one of us, medicine. Look, this isn't about making things a tiny bit faster. As Sarah Fruh says here, this is a fundamental shift in how we discover things. It's like we've just added a brand new pillar to science itself.
So we're going to start at the micro level, right inside our own biology. This is where AI is doing things that not too long ago would have taken an entire scientific career to accomplish. And it's where this whole revolution feels the most real. What you're looking at here is a massive, almost unbelievable compression of time. You know, the old way of discovering drugs, all that painstaking lab work, screening millions of compounds, endless trial and error, well, that's being completely upended. AI models can now blast through molecular candidates in seconds, turning a process that took years into just a few months. It's a total game changer.
And the pace is just staggering. Think about it. Just a couple of years ago, AI models were pretty good at writing an email, but they really struggled with complex scientific reasoning. Fast forward to today, and we have tools like AlphaFold 3 that can model the very machinery of life with mind-blowing accuracy. And with what's on the horizon, we're shifting from just using AI as a tool to having it as a scientific partner, one that's capable of real insight.
Okay, so that's the software. Let's zoom out from the code to the hardware that makes it all possible. Because all that incredible digital intelligence has a very real and very, very large physical footprint. We're talking about the massive engine that's driving this whole revolution.
We are not talking about some souped-up laptops here. We are talking about a trillion-dollar global infrastructure build-out. These data centers, they aren't just server farms anymore. No, they are being built from the ground up as what you can only really call AI factories. The goal is to make them function like single, massive, integrated computers.
And the heart of these factories? It's the silicon. Forget Moore's law, that old rule about performance doubling every 2 years. This is so much faster. Companies like NVIDIA are on this brutal 12 to 18-month cycle, pumping out new super chips that offer these insane exponential leaps in power. The jump from today's workhorse chip to the Rubin chip in just a couple of years, it's just wild. So, we've got all this incredible power. What does that actually mean for us? For the way we work every day? Let's zoom out again, this time to the human layer. What happens when you put these kinds of super tools into the hands of millions and millions of people? The goal here isn't just to automate jobs away. The bigger, more powerful idea is something called superagency. And the key here is that AI acts like a partner, right? A co-pilot that doesn't just do tasks for you, but actually amplifies your own skills, your own creativity, and your own effectiveness.
But, and this is a big but, there's a huge disconnect between what the bosses think is happening and what's actually going on. Leaders are dramatically underestimating how much their teams are already using these tools. While executives think maybe 4% of their people are heavy users, the reality is more than 3 times that. This adoption is happening from the bottom up, whether leadership sees it or not.
And this whole shift, it's not just about efficiency. It's creating a very clear economic divide. The early data is showing a massive 56% wage premium for workers who are AI literate. This isn't some trend that's coming in the future. It's happening right now, and it is completely reshaping what skills are valuable in the job market.
Okay, but all this incredible progress, it creates a new kind of challenge. As we zoom out even further, this surprising and frankly critical dependency starts to come into focus. This whole revolution, the software, the hardware, the supercharged workers, it all runs on one thing.
And what is that hidden cost? Well, all this computational power consumes a staggering amount of a very real-world resource, electricity. The demand for power is growing so fast that it's creating a bottleneck that, honestly, nobody was really prepared for.
So here's the crucial point. By 2030, data centers are on track to double their global energy consumption. We're talking about a demand of almost 1,000 terawatt hours. That is an amount of electricity comparable to what entire countries consume just to power the engine of AI.
This energy demand is so extreme, it's actually sparking what people are calling a nuclear renaissance. Tech giants are not waiting for the grid to catch up. They're basically becoming energy companies. They are directly investing in restarting old nuclear plants, funding brand new reactor designs, and even making deals to buy power from the world's first commercial fusion plant. That's how critical, reliable power has become to their plan.
Okay, so now that we see the planetary scale of this infrastructure, let's zoom out to the geopolitical level. Because when you have a force this powerful, the world starts racing to create a common set of rules to try and manage it.
The first major attempt at a global rulebook is the EU AI Act, and it takes a pretty pragmatic, risk-based approach. So instead of a one-size-fits-all law, it categorizes AI by risk level. Things like social scoring systems, banned outright. High-stakes stuff like AI in medicine or hiring faces really strict rules. And for things like chatbots or deepfakes, the main rule is just simple transparency. You have to know that you're interacting with an AI.
But getting a global consensus on these rules, yeah, that is far from certain. There is a really stark cultural and political divide here. In many Asian nations, you have around 80% of the population seeing AI as a net positive. But in North America, that number is less than 40%. This fundamental difference in how people see this technology is going to shape how different parts of the world regulate and use it.
All right, finally, let's zoom out to the furthest possible vantage point, the future that all of this is building toward. Where does this exponential curve of software, hardware, and human adoption ultimately lead us?
We're moving beyond the simple question and answer chatbots to something called agentic AI. And the key difference is autonomy. You don't just give these systems a prompt, you give them a goal. The agent can then research, plan, and execute across different apps and platforms to actually achieve that objective all on its own.
So what's the next logical step after that? Well, it's something people are calling swarm intelligence. So instead of one giant, all-knowing AI trying to do everything, you have a whole team of specialized agents. Maybe one for research, another for coding, a third for security, and they all collaborate to solve complex problems. This is the vision of an autonomous digital workforce, where AI shifts from a passive tool to an active problem-solving team.
So there you have it, the full blueprint. From a single protein folded on a computer screen to trillion-dollar factories to the global energy grid needed to power them, and all the way to the rulebooks trying to steer them. The entire interconnected architecture of the AI revolution is being built right before our eyes. The only question left is, what are we going to build with it?